Well, hello. Welcome back to physics. Today we're going to talk about some more basics. Today specifically we're going to be talking about converting inside the standard system that we use every day here in the United States. What you're going to learn? Well, you're going to learn about the factor label method. When this is over with, you should be able to convert using the factor label method. We're not exactly going to get into the metric system just as of yet today. This will be actually tomorrow night. But we are going to talk about some dimensional analysis. This right here are the conversions for length. I would get these down. I would write these down in your notes, even though I'm not going to have it up here for very long. I pause it, write them down. It's going to be very beneficial to you. The same thing here for weight. Time. Once again, I would get these written down. Capacity. Capacity deals with volume or liquids for the most part. Alright, how to convert? Well, the first step is you place a 1 under the measurement to be converted. Then we're going to write down the next conversion in sequence, but it's important to make sure that the units will cancel out. And you're going to see examples of this. The third step is we're going to multiply straight across. The fourth step is we're going to divide. So on the first one, as you can see here, what we wanted to convert was the 2 gallons, and we wanted to go into ounces. Well, our first step said to write it so that there was a 1 underneath it. So the first part of this is right here, where we took the 2 gallons and put it over 1. That's the first step. Take what we have, put it over 1. The second step says to write down the conversion next after it that will allow us to be able to start converting this. Well, there are 4 quarts in a gallon. Well, how do we know we're going to put 4 quarts on top or 4 quarts on bottom? Well, the important part here is to make sure that the units cancel out. Because gallons are on top here, I've got to make sure that gallons are on the bottom here so that they cancel out. What we have next then is I'm now left, the only units I have left are quarts. I have a conversion that says 2 pints in a quart. Once again, how did I know to put pints on top? Well, I put pints on top so that the quarts would cancel out. I have quarts here on top, and they both cancel out. The next step is we have a conversion that says there are 2 cups to 1 pint. Again, I put the pints on bottom so they would cancel out with the previous one. The last step then is we have a ratio, conversion factor, that says 8 ounces to a cup. I put the cups on bottom so that they would cancel out. So again, I would put the 1 under the measurement to be converted. I wrote down the next conversion of the conversion in sequence. I made sure that my units would cancel out. The third step is where I'm at right now. I'm going to multiply straight across. 2 times 4 times 2 times 2 times 8 gives me 256 ounces. The easy part here would be the bottom. 1 times 1 times 1 times 1 times 1 is 1. Or we could just say, as we said earlier, 256 ounces. Here's another example. The first step said to take what we're trying to convert. Here it is. And put it over 1, which is what we did here in the first step. We then used our conversions from minutes into seconds, which would be this one right here. In 1 minute, there are 60 seconds. So 1 minute, 60 seconds. We put the seconds on bottom so that they would cancel out. The seconds cancel out. And then we continued with the process. The next conversion after minutes is hours. In 1 hour, there's 60 minutes. And then there are 24 hours in 1 day. When you multiply this across, you're going to get 92,100. divided by 86,400. Well, when you divide those, you get the 1.1 days. Let's work through a problem here. 45,000 ounces into tons. I've already done the first step by writing it over 1. The next step is to write down the next conversion factor. Well, after you get into ounces, we have a conversion that says 16 ounces is 1 pound. So I would say times, and I'm going to write the 16 ounces on bottom so that it will cancel out with the ounces on near the top. I'm going to write 1 pound. Well, now I know there are 2,000 pounds in 1 ton. 2,000 pounds, I'm going to write it on bottom so that it cancels out with the pounds that are in the previous conversion. And I'm going to write 1 ton. Now when I go through this, all of my units cancel out except for the ton. So my answer would be left in tons. What you find out is we get an answer of 1.4 tons. Let's do another example here. I'm going to pause it and give you a chance to work this one out. Well, I've got it worked out here. We find out that there are 63,072,000 seconds in 2 years. How do you know it's done correctly? Well, my years canceled out, my days canceled out, my hours canceled out, and my minutes canceled out. So the only thing left then were the seconds. Okay, the thing I want to talk about now is dimensional analysis. It's a big word that really just goes back to what we were talking about, canceling out units and being able to effectively cancel out units, because it's going to be important, because there's going to be times in physics where you're not sure what your units you should put on it, and you can always go back and look at your problem and figure out what the final units would be. So, an example here would be in the top one. Simply think about what would I do if I was just treating it like variables. So a lot of times I might rethink of this one as m over s times s squared over m divided by s. And I would probably get rid of this m over s on bottom, because this right here means to divide, which we know that how do we divide fractions? We change it to multiplication, and we do the inverse. So again, what that allowed me to do is to get rid of that, because instead of dividing now, I changed it to multiplication and inverted it. Well, what can I put on the bottom now? Well, I just put a 1 to replace it. So now we look through here and we ask ourselves, what units cancel out? Well, the meters canceled out. These seconds canceled out. And if I had an answer, let's say my answer was 64.3. It would be 64.3 seconds squared. And that's what my final answer would be with that. So dimensional analysis is really just like canceling out variables. Something you've been doing since probably 7th grade, maybe 8th grade. The next one is we want to find out, do these indeed end up being the same? Are they equal? Are they equal to each other? Well, we have kilogram meters per second minus kilogram meters per second. Is this equal to kilogram meters per second squared seconds? Well, I know that my rules for subtraction, if I would do, let's say, these are the same, kilogram meters per second, kilogram meters per second. Think about it like a variable. 4x minus 3x gives me 1x. What I want you to realize is that my variables didn't change. So when I subtract, my units are not going to change. So kilogram meters per second minus kilogram meters per second, nothing's going to cancel out. What it really turns out to be then is kilogram meters per second, is that equal to kilogram meters per second squared times seconds? Well, I'm going to put this last one over 1, and now I'm going to start canceling things out. This second cancels out with one of those 2 seconds, and what am I left with? Well, they are equivalent to each other. That's just dimensional analysis. We're looking at the units. We've got one last problem here. Let's see what we can cancel out. Again here, we're dividing by seconds. Well, that's seconds over 1. So I can rewrite this as kilogram meters per second times an inverse second. An inverse just means I inverted this, so it's 1 over second. So it's inverse seconds. Nothing cancels out, so when I multiply it, I get kilogram meters per second squared. So in dimensional analysis, don't let these units mess you all up.